Hola, buenos dias. My name is Nicole. I'm going to be talking about refactoring today. So, a little bit about me. I'm an engineer. I work at a company called Avant that's in Chicago. I've been coding professionally for about 2 years now. I learned online, mostly online and from meetups. And I have 2 cats, Ella and Seabass. You might see them on the slides today. So a little bit about where I work. The company is called Avant. We are an online lender in Chicago. We issue loans to people. And we've been issuing loans for about maybe 4 years now, and we've also started to sell our platform as a service to banks so that banks can use our app to issue loans as well. So I am on the loan servicing development team, so that means that I handle a lot of the code that does financial calculations for a person's loan. Specifically, I work on the payment plans, and we're going to talk a bit about that because that's largely what I refactored. So what's a payment plan really quickly? So when somebody takes out a loan, they agree to, they take out a sum of money and agree to pay it back over a certain amount of time. And sometimes, life happens. Customers might have something bad happen. Maybe somebody loses their job or has a medical emergency and they can't afford their loan anymore. And we don't want to hurt our customers. We want to help them, right? So a payment plan allows us to change the loan, change what's due over time. Maybe we forgive fees. Maybe they pay less so that we can accommodate a customer for, when life happens. So our company is a recent startup, and we work with a Rails app. So thanks Rails, because it helped our company get off the ground pretty quickly and iterate quickly with multiple pivots, as startups tend to do. So as our company grew quickly, so did our code base, right? So now we find ourselves in this place where we have a rather large monolithic code base that we are in the process of breaking up into smaller microservices. So it's, the typical problems of scale and tech debt. So this comes into why I'm talking about refactoring. So I've been working on a refactoring project for approximately the past year now. So that's payment plans. So about a year ago, I was noticing that each time that I had, a ticket to add a payment plan or modify a payment plan, it was getting harder and harder to modify, in terms of time, in terms of technical costs, and then also in terms of safety, to not release any bugs and whatnot. And actually, a year ago, we were also asked to create a type of payment plan that challenged some of our core assumptions as a business. So we were asked to make a payment plan that changed a customer's interest rate over time. And that actually was something that our system didn't support. So we found ourselves in a position where we had to refactor, had to revamp our current architecture so that we could support that functionality. So I'm still refactoring, actually. A year later, I'm still working on this project, though we did hit a major milestone right before, the day before I came here to Colombia. So yay, that was exciting. The project has gone pretty well, but of course things could have gone better. Not everything went perfectly, and it was a major learning experience for me. So you can learn from my mistakes because hindsight is 20/20. So what we're going to cover today, the importance of planning and design, how to manage change, both safely so that you don't break things, and without losing your sanity when you have multiple code paths, right? And also the emotional side of a refactor. So first, let's cover the basics. What is refactoring? So refactoring is change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. Gracias a Martin Fowler for that definition. Shout out, Cat. So let's examine this definition a little bit. So hindsight Cat comes in, notices, without changing observable behavior. Well, we changed a lot of behavior in our refactor. So what we were referring to as a refactor at work for the past year wasn't really a refactor at all. It was a complete rewrite of a system. And sure, we did refactor some things as a part of our rewrite, but it was a rewrite. So what this talk is not. This talk is not about refactoring, and it's certainly not about the perfect refactor. We changed a lot of behavior. It was not a no-op change or a no-operation change. So what we're going to talk about is my refactor, my rewrite, which went about like this. Just kidding. It went a lot better than that. So again, not a refactor, it was a rewrite because behavior absolutely needed to change. So we ended up, adding some new features and also rewriting our existing functionality to support the future of our company. And it was also a learning experience. So some key indicators, like when should you rewrite? So as I mentioned before, you should rewrite, an indicator that you might need to rewrite parts of your system or when core assumptions about your business have changed. So like I said, all of our app had been built with this assumption that one loan has one interest rate over time. And when we changed that assumption, our system actually couldn't support it. So when you're being asked to build something that your system literally cannot support, you're going to have to rewrite some things. So where did we start off with our payment plan architecture? So we first had an inheritance-based system. So this worked pretty well, like when we had a few payment plans that all shared some certain behavior, and then, the certain subtypes of payment plans got more and more specific. So a pretty good use case for inheritance, right? Here's our, subclass of payment plans. But over time, things got more complicated. More functionality was requested for each type of payment plan. They started to diverge in weird ways. So sometimes they shared behavior, sometimes they didn't. And it was really hard to tell what was going on between the base class, the subclass, the model, and then also some modules that were included, maybe some other stuff coming in from the front end. So we really needed to clean that up, right? So what are the needs of our new system? Well, first of all, we need to support that new functionality that has been requested, but we also need to clean this up so that we have a single source of truth for our future payment plans, so that we know what any one plan is doing, so that we have some ease in adding a plan or modifying a plan, and safety in doing so. So first things first, take the time to understand your domain. So I had been working on the payment plan system for about a year before embarking upon the refactor. So I knew it really, really well, knew it intimately. Take the time to understand the pain points, like what's hard about it, what's difficult to change, what don't you like, right? And make sure that you document. Take the time, like while you know the system so intimately, to document the current state before you start, and then to continually update that as you go. So that's something that, in hindsight, I wish I had done a little bit more, especially up front. So I added a lot of great documentation about halfway through, but I think it would have been really helpful for all parties involved if we had been documenting a bit earlier. Also, take the time to design. So you've been given this golden opportunity to rewrite your system, right? You want to make sure that you get that right, and you take your time with your design decisions. So, of course, understanding requirements is a key part of design. Also, brainstorming with stakeholders. So also make sure that you identify who your stakeholders are. And they might be people that you wouldn't have expected. So maybe there's some person downstream of your data in like a different department that uses the payment plan data for some critical report. They're a stakeholder. Any type of change that you make to that system might affect them. So you want to include them in your discussions about the new way of things. And also make sure that you think outside of the box. When you understand a system so intimately, it's really easy to get trapped inside of the mindset of, this is how this thing works. And you think about it in that way because that's how it is, right? So make sure that you take the time to, break out of that box, break out of that paradigm, and see how it could ideally be. So with all of that, now that you've taken the time to document, design, and understand your domain, we've got a set of guiding principles. So our set of guiding principles were, I guess, rather opinionated, and I feel like you could have a whole talk about just these principles, but what we chose to do were to favor configuration over inheritance. So we wanted our payment plans to be modular. We wanted to be able to compose them from their behavior and not navigate an inheritance framework. We wanted to favor immutability over mutability. So in the olden way, we would modify state on the fly, which made it really difficult to debug and version and modify and model change over time. So we wanted to favor more of a mutable approach. We also decided to favor explicitness over implicitness. So being explicit in, again, like the configuration and your definition of a plan, having one source of truth of like, this is explicitly what this thing is doing. And even if it's a little bit redundant, even if your names, your class names get really long or your variable names are kind of long, you know exactly what it's doing. And then also we're favoring separation of data and behavior. So instead of querying for the things and in the same method call, you know, maybe manipulating the things, maybe doing some calculations, all of that, query separately. You can test the result of that query and then, you know, do whatever you were going to do with that set of data. So given that set of data, do the thing. So with those guiding principles in mind, we got ourselves a plan. So what's our plan? Define our plans in configuration, have single-purpose action-oriented classes that encapsulate all the side effects that we want for a plan, and then tie those things together, tie the definition and the actions together in a system that can just run through those based on definition. So yeah, now that we've seen where we started, where are we going? We're going to this new way where you can define a payment plan. We have our CATS payment plan defined in a YAML configuration file, and that's the one source of truth. And then whatever type of action occurs, say, you know, you start the plan, if all the plans can go through the same start class, where if my definition says that I forgive fees, I forgive fees. If my definition says that I freeze interest, I freeze interest, so on and so forth. So a big shout out, this is one of the things in our toolkit, a big shout out to the Verbalized Jim. This is a gym that a few of my coworkers, yes, so you may have noticed that we have this like verbalize, there we go. Yeah, including verbalize action here. What that is the Verbalized Jim. So a few of my coworkers actually created this gym, and it's just a really simple way to define a single purpose, like functional style, like action-oriented class. So here's an example of a class using verbalize. We have the action that this class performs. So the naming is very action-oriented, so it's actually like the verb. And we take some input, we define one public call method. And so that's just one action-oriented method. And the Verbalized Jim is really just some shorthand syntax for, instead of defining your class call method and then instantiating your class, and then just to define your instance call method, verbalize gives you some of that. It also does a little bit of other things under the hood, so essentially it returns a result object that you can then check for success or failure. So that's kind of a nicer thing that verbalize allows you to do as well. So now that you see some of the tools we're using, our guidelines, we know where we're going, right? But how do we get there, and how do we get there safely without breaking things? Again, planning is so important here. So you need to plan out what to change and when, especially when you are migrating, a system that's under use from the old way to the new way. So resist the urge to change all the things at the same time. It's very tempting to be like, oh yes, I have this new way. I'm going to roll it out. We're just going to merge this giant PR and boom, here's my new way. That's pretty risky, right? Like if you merge all the things, you might break all the things too, right? So our plan was to start with one subtype. It seemed a pretty natural way to go since we have multiple types of plans. So we start with one subtype, one subclass type, and then move it over to the new system. But first we have to build out the new system, that new path for that new type to go down. And then only that type goes down that path. And then once that path is complete, once we have one plan going through this beautiful new code path, then we'll start to put more and more plans over that code path. So how do you decide what goes down the new path versus the old path? That's where seams come into play. So what is a seam? Am I talking about, where your clothing is stitched together, like some, pair of jeans? In software, a seam is a place where you can alter behavior in your program without editing it in that place. The term was coined by Michael Feathers. So a good seam will help you manage what goes through the new code path versus what goes through the old code path, which will ultimately help you maintain your consistent public interface throughout the course of your refactor. So we'll look at how, a case study of how we did that. So here's some old code, some old payment plans code. Here's the old CATS payment plan. And basically the way that we decided to go down the new path was, if the new path is applicable, so from the old code, we delegate to the new code if it's applicable. So here's our seam. Our seam determines whether we go down the new path or not. So that allows us to change the behavior, like call the same class and change the behavior that occurs without actually changing the implementation of the old method here. And here we've also isolated our logic, detecting the old versus the new in a nice little verbalized interactor class that isolates that. And I would also recommend definitely isolating that logic as much as you can, because that's where it gets kind of messy. Like, if it's this new type of plan, it goes down this path. If it has this attribute, it goes down this path. Like, what's old, what's new? Halfway through, when you have like 3 plans on the old way, 3 plans on the new way, it's really going to be helpful to isolate that. So then once you have your maybe like one type of plan on the new architecture, you can actually roll out your new public interface. So once your new public interface is ready, you have your nice naming conventions established and your patterns established, you can just delegate to the old code from your new code. So here, there's our seam again. This time it's just, if you're old, do things the old way. Otherwise, yay, we have a new code path. So in our refactor, as I mentioned, our rewrite, as I mentioned, we ended up changing some of the data implementation, or like I mentioned that our core assumptions changed about a loan having 1 interest rate over time. So that had major implications for the way that we modeled our data and the way that our tables were related. So we ended up overwriting some Rails methods and some Rails associations and adder readers to be able to maintain a consistent public interface while these data structures underneath were changing. So we essentially migrated from like the has many belongs to and put a join table in between and overwrote the association, the has many association. Similarly, we had one column, say the interest rate column on a loan, and we actually overwrote that association to read from a table. So we'll look at an example of that here. So here's our nice little product class, and here's where we rewrote the association. So instead of our has many payments, we renamed that to has many directly associated payments. It still goes through the payments table. And then it also has many payments versions. So that's our table that that's our class that ends up having a has many and belongs to many relationship. So that's our join table there. And here's where we overwrote the has many relationship. So we could still call, we have like maybe half of our loans have the payment versions, half of them don't. We still need to be able to support things that happen with payments for all of the loans, and we need to maintain parity between all of the functionality that we have. So basically, here's our here's our seam of does our payment version exist? Yeah, or if not, go through the direct association. Otherwise, let's go through the payment version to grab all those payments. So here's our seam in that case. Otherwise, here's the example of the overwriting of adder reader. So instead of having an interest rate column, we wanted to go through this table. So are there any interest rates for the products? If so, yeah, let's return the rate from the new table. Otherwise, let's just read off of that column. So now that we've talked about implementing change in your code, how do you release change? And how do you do so safely? Ship code dark. What does that mean? It means merge your changes, but don't make them live yet. So why would you do something like that? It basically helps you to keep moving quickly, keep up your momentum without compromising on safety. It also allows you to break things up into piecemeal changes, right? So that you don't have to change all the things at the same time and then flip a switch to make that new code live so that you can break up, pieces of this major piece of functionality into some minor pull requests. And it also facilitates collaboration so that I could work on one thing, somebody else could work on the other thing, and maybe both of those things are necessary for the the entire feature, but we can collaborate and parallelize. It also allows for a pretty long or a good test cycle as well. So, especially if you're making riskier changes, it's really, sometimes you want to have the ability to, QA in production before you actually fully release the change. So how do you ship Dark? Feature flags are your friend. So what's a feature flag? A feature flag basically allows you to enable or disable a certain feature. So you can flip the on or off switch essentially on your code. And how do you use a feature flag? The way that we use those were through environment variables. So we would just set an environment variable to turn something on or turn something off. So the big benefit in that, again, is that you can enable or disable code without actually reverting or redeploying. So let's say worst comes to worst. Thankfully this didn't happen, but worst comes to worst. You get all of your changes ready, you merge them, everything's awesome, and then just things start to break in ways that you didn't expect. You can, instead of having to revert your pull request, wait for your build to go green, redeploy to the app, instead of doing all of that, you can just unset the environment variable, basically flip the switch off, and then that functionality is no longer live. So it really allows for a lot of safety. And also, while you are releasing changes, make sure that you don't forget the in-flight population. So what is the in-flight population? That's the population of, say, CATS payment plans, right? So we have the payment plans for CATS. Those plans, they were all created under the old way, and then we released this new way. What do we do with the ones that are active that still need to be serviced? Do they go down the old path? Do they go down the new path? That type of thing will depend on whatever your problem set is, but the in-flight population deserves a lot of special consideration because you don't want to break something's functionality that's already, existing. So your seams will really help with that. So the importance of a well-thought-out seam. So let's look at an example. So here's our new payment plans, start class. This is how we're going to start a payment plan. Here's our feature flag. That's our environment variable. So if the new plan is live, then that will be a truthy value. Otherwise, it will be false. And this new path is only ever going to get hit if that environment variable is set, or if that feature is live. And here's our legacy interface, right? So that's our old code. And that only gets hit if it should be hit. So if our new path is not live, we always go through the old way. Or if it was not created on the new architecture, right? If it's not a new thing, we want it to go down the old path. So change can be pretty risky, right? So how do you manage that risk in times of change? Test all the things. Tests are so important. And get a test plan. Make sure that you collaborate with your stakeholders to develop that test plan so that you have a full set of very thorough test cases that you've thought about. And automate those that make sense to do so. So automate all of your expected test cases and your expected edge cases, and then maybe, especially when you're doing riskier changes, throw up your changes onto a staging environment and allow somebody from the business side to, run through the app and see, try to break it, basically. Do more of exploratory testing on your staging environment. So yeah, and especially integration tests are so important while you're changing the internal implementation, while you're doing a rewrite. So those will help you to catch bugs before you release them. They'll also help you maintain your sanity while you're changing all the things. And expect failure. So when you're thinking in the expecting failure mindset, idempotency is really important. Make sure all of your actions are idempotent. So what idempotency is when you call an action twice or in amount of times, you get the same result. And also be sure to compartmentalize failure. So if you expect failure, you can compartmentalize it. Error handling is helpful there. Use transactions so that if you're doing database, if you're hitting the database, you don't wind up in a weird state in the event of failure. And then again, strong integration tests. So on the left-hand side here, this is actually this is a screenshot of an integration test that I wrote. And I felt pretty ridiculous when I was writing this test because I was calling like this weird chain of events, like calling things multiple times, reversing the thing, calling it again, maybe calling it 2 or 3 times. But after each time, I expected a certain state for the database. So I had a set of expectations, like for the database, for attributes, for whatever. And that actually helped me sniff out a lot of bugs, so I didn't release them, right? So that was pretty cool. Again, in hindsight, here we go with good lessons from Hindsight Cat. I do wish that I had let the tests drive the refactor a little bit more. So if I were to start, looking back, I would have started with my tests. I would have started with them for understanding the domain and also for documenting the domain, so letting that drive your documentation, and also letting your tests drive your interface design and give you more feedback on your design choices. So yeah, things to remember while you're doing a rewrite. Before it gets better, it gets worse. Halfway through your rewrite, halfway through migrating things over from an old way to a new way, you're going to be in a state of inconsistency with like half of your stuff on this old framework, half of your stuff on this new framework, and they both have to behave the same. The logic that controls that can get kind of messy. So remember, it's going to get better at the end. You're going to get to delete things. Your seams will help, and then just try to minimize complexity until then. Also, remember to take the time to clean up after yourself as you go. So one thing about when you ship code dark and you use feature flags, you're naturally going to have a deprecated code path at the end of your release. Make sure that you give yourself time to delete that dead code. It feels so nice to delete that too. Also, if you notice some tests that don't make sense anymore, right? Like because you've deprecated this code, or like this is testing something that we used to do back in 2014, delete it. In hindsight, yes, hindsight tip from Hindsight Cat, build that time into your estimates as well. So make sure that you think about that up front and make time for it. So yeah, rewriting a system while it's being used is really hard. So you are really important. Remember to take care of yourself. And a major rewrite is a bit of an emotional roller coaster ride, and it's kind of daunting. And it's a marathon, not a sprint. You need to avoid burnout. You don't want to lose confidence. Like halfway through the rewrite, I was definitely getting a little bit burnt out. I was losing confidence in myself and my own abilities to code at all. I was really tired, and like, how do you maintain your focus on that larger vision? How do you keep your endurance up while you're in the midst of this major rewrite? Remember the basics, right? Like, have you slept a lot? Like, have you been getting enough sleep? Did you eat today? Like, are you just sitting at your desk coding, and like you forgot to eat? Exercise, like go take a walk outside, go take a break. Prioritize your mental health. So yeah, and most importantly, like, we love to code, right? Like, remember, it's fun. So have fun when you're reviewing each other's pull requests. Use weird emojis. These are things that we actually we do at work. These are real screenshots. So we had, thumbception over here. Our product manager has his seal of approval. Sometimes it's a seal. Sometimes it's the Singer seal. Yeah, so we have a lot of fun. And yeah, refactoring is hard. Managing change is hard. Doing so safely without breaking things, and also maintaining your sanity while you're juggling all the different ways that this one thing could flow through your code. So what are some takeaways here? In your next rewrite, make sure that you take the time for planning and design, for documentation, and to continually update your documentation as your changes are updated. And make sure to not try and change all the things at once, right? Release code, ship code dark, and make sure that you choose your seams wisely, that you really think about, like, where should my switch go? Where should I alter this behavior in place? And let your test drive your rewrite. And most importantly, take care of yourself. That system's not going to rewrite itself, right? It needs you. So muchas gracias. I'm on Twitter. GitHub.